Hello everyone. So welcome to today's webinar where we discuss on a very pertinent topic, that is EMS, Energy Management System. We are joined in by Suhas, Sutar, Satish, Reddy, Kashish, Arora, and we have Venkat Rajaraman joining very soon. And saying so, hearty and warm welcome to all of you to today's webinar. Thank you for making your time. And yes, it's a very important topic, and this is the third season of IESA Chat Show that we organize every month. The first one was with CRU, the second one was with Benchmark Minerals, and this one, I thought that what could be a better time than to organize it for our own sector. So telling so, I would quickly bounce back to my panelists. I would request if everyone can introduce themselves. Suhas, starting with you.
Yeah, thank you and good evening all. And I really appreciate all attendees. Now I can see 61 participants joining in, and thank you for taking out time and attending this webinar. So I'm Suhas representing Replus Engineering Private Limited, and we are a turnkey BSS solution provider and even lithium-ion battery pack assemblers having 1 gigawatt hour of facility. So for this and pertaining to this webinar, we are also providing EMS solution along with the turnkey solution for BSS. And in all, till date, we have deployed more than 100 megawatt hour of BSS and going ahead with execution of around 1 gigawatt hour of BSS projects this year.
Thanks, Suhas. We have Satish. Satish, would you like to go next?
Hi everyone, good evening. I'm Satish Reddy, founder and CEO of Xbattery. We are building a indigenous BMS, battery management system for both large-scale energy storage as well as the high-end electric vehicles as well. So we are building our product is called Bharat BMS, which has this the modular architecture to support our clean tech transition. And I'm happy to be here.
Thank you. Hi, Neehar. Would you like to introduce yourself?
Hi. Thanks, Debmalya. Thanks for the opportunity to showcase. And everyone, so I'm Neehar Jathar. I'm the head of product at AmpereHour Energy. I lead the EMS vertical at AmpereHour. We are a turnkey BESS integrator with over 120 megawatt hour deployed and about 2 gigawatt hour in the pipeline to be executed over the next 18 months. I look forward to a very constructive chat.
Thank you. Venkat sir, would you like to introduce yourself?
Hi, thank you, Deb. Thank you, everyone. I'm sure it's going to be a very interesting session. I am the founder and CEO of Cygni Energy. We are in the business for the last 10 years. We very similar to the other folks. We do battery pack design engineering, cell level and pack level characterization and qualification. We do the manufacturing, and then we do the pack analytics and second life support as well. And in this particular case, we also have sort of deployed our BMS that we had developed. That's why I think this conversation is going to be very useful, and looking forward to a great discussion there. Yeah.
Thank you. And last but not the least, Kashish, would you like to introduce yourself?
Hi, everyone. Thank you, everyone, for joining in. Feeling obliged, I guess, very much good, like the panelists, and thank you, Dave, for organizing this. To myself, Kashish Arora, I'm in founder's office at Newen Systems. So we are PCS and EMS manufacturers and turnkey system provider. So we are proud to say, like, Make in India, true Make in India, we are moving into that direction. Happy to address the question in the meetings.
Thank you. So as you all know, early last month, government had passed an advisory that all amendment to the viability gap funding scheme, which says that EMS, the software part at least, has to be done in India. Now, after that, of course, a lot many queries started to come. Is India ready to do that? Do we need timeline to do that? Is the software part is okay, fine. Is the hardware also something that we are doing in India? And more pertinent to all these discussions is EMS. What everyone looked as a very low value item in the total project cost suddenly became important. So I want to understand with Venkat, sir, you first. What is a EMS? So if you can explain to the audience what is a EMS and what is its criticality in the BESS system?
Got it. Okay. So let me try to sort of put it in a way that's easy to understand. EMS is the brain of a large-scale BESS system, right? So I would consider that a BESS, right, without a EMS is a fairly an idle hardware. And once you have an EMS, it becomes a very dynamic, revenue-generating, grid-supporting asset, right? So that's the way that I would put this EMS at. In terms of functionality, what it does, I think it quite, it does quite a bit of functionality. We'll get into the details subsequently. But, it does, not only sort of a monitoring of the assets which are there, but also provides the, communication, with the grid. And it also sort of allows the asset managers to sort of deploy the asset in a very useful way. That's how I would put it, Dave, actually. Yeah.
Thank you. Thank you. Coming back to Neehar. Neehar, a report globally says that of all the battery failures that has happened, battery per se has been the least factor which has resulted in the failure. And EMS stands out at the top of all these failure reasons that poorly configured EMS led to the failure of the project. So can you tell us a bit more about the criticality of this?
Yeah, so Dev, I think like as Venkat very aptly said, batteries on their own are a dumb asset, right? They are not inherently revenue generating, unlike the rest of RE that we are used to. It's a buffer. It has to be directed to generate revenue. But I look at EMS in two ways. One is sort of internal to the plant, and one is external to the plant. And when we talk about safety and correct operations of a sensitive asset like BESS, the internal to the plant aspect of EMS really becomes very important. How we configure the safety limits, how we configure on voltages, on temperatures, on rate of change of all of these parameters becomes critical to how we can run these plants. Secondly, there's a lot of data that comes out of any of these BESS plants, right? We have a plant running that's a 50 megawatt hour plant that's generating about 90 GB of data a day. Now, how we can use this data well to sort of predict failures, how we can use this data to analyze early before there is a fault event or before there's a thermal runaway event, is really how we can build up the capability to run BESS safely. And then, of course, comes the part on the market side, right, where we deploy this asset to its maximum potential, charge and discharge at the right time in the right markets, do what the grid requires us to do in order to support it. But I think both of these aspects are quite important.
Thank you. Kashish, coming to you, I want to understand what goes inside. Okay, we understand the software part, but then on the hardware part, what goes inside making an EMS?
So Dave, to add on the goes into an EMS is definitely one is a base CPU, like in anything is a main processing unit or is a main controller. It can be a PLC controller, it can be a self-derived embedded controller, it can be a edge-based controller. So it's like basically it's a basic is one controller. Then it is all other auxiliaries which come into. So they are in a, like Neehar said, you get when you're having a 40 megawatt of plant, you're getting so much data. So data needs to be communicated in a various protocols. So there has to be hardware, DI, DOs, then there are analog signals, then there are depend upon a hardware signals. That's how the input is derived. And then we have the power supply, auxiliary supply, IoT gateway, firewalls, and last but not the least, the visualization part, the local SCADA, the local HMI screens, where all this data is coming into play. So this is a brief summary of what all goes into hardware. But over and above is the is the person who is making it, the person who is coding on it.
Yeah.
Okay, that's
Yeah,
what
yeah.
define what the EMS tool is. That EMS is more of a software than a hardware. It's a solution.
Understood. Thank you. Satish, I'm taking a cue from what Kashish said, that it's about the software mainly. So as on today, are we okay to say that the software part is, we are ready on the software part for EMS?
So before answering that question, we need to understand, where the EMS gets the data from, right? Or the systems, other systems that the EMS has to communicate to. So the one thing you can say, obviously, power conversion, which is PCS. You should be able to, as a EMS, you should be able to control it, basically, like a direction of the flow of the power, right? And on the other aspect, you need to communicate to the batteries, obviously via the BMS. So the BMS are obviously sophisticated enough to push the data. So your as a system, EMS system, you should be able to pull it, right? And also another thing is probably through the edge controller, we have to talk to the grid also, right? So when I say grid, I mean the load dispatch centers, right? So I'm talking about some maybe centralized SCADA system at that grid level also, right? So all these communications, when the EMS has to talk to all this, probably through in the hardware via edge controller. But when it comes to the software, again, each system may use a different kind of protocol, right? So some might use Modbus, some might use some other system and all. So the edge controller or any other system, we have to streamline that or make it into a uniform communication channel. And then, yeah, I think our EMS should be able to communicate, right? That's once with the support of the common communication channel, such as Modbus, you should be able to, talk to the devices which are local to the base, but also the remote also, let's say your load dispatch centers systems as well. Yeah.
Thank you. And Stefan, I would come to you at this point of time and know about what has your experience been on the global part. Have you seen EMS feeling, or maybe at that point of time, what amount of criticality have you seen in projects?
Yeah, good question. And that's exactly what I was thinking, hearing the speakers so far. We've heard the architecture and technology that you need to make something work. But if you're connecting a hundreds of megawatt capable system to a transmission grid of a country, you better make sure that it not only works, but keeps working for years. I'm thinking of redundancy, failover safeties, no single fault and even dual fault systems should cause the solution to shut down or suddenly disrupt the stability of the grid. I'm thinking of cybersecurity, backdoors, all that kind of stuff. So one of the things you mentioned, this VGF supported project should now have indigenous software. It makes complete sense to me. Because it is so easy with such powerful, capable system to derail a grid completely and to make a country go black, go dark. It's very easy. So I think we should not forget in best case, standards-led design and safety of these energy management systems. We should not forget that. It's not enough to make it work. It's very important to make it safe and to make sure it keeps working and that nothing stops it. Because if you allow that opening, you'll be going back to candles very soon. I think either it's me or it's Deb that has a connection problem.
No, I think Debmalya has connection problem. We can hear you.
All right. maybe he has a power failure.
He needs BSS.
Maybe at the appropriate time, Stefan, because right after the the redundancy, this could be the right the importance stressing that more
Yes,
actually.
he's just trying to prove my point.
Hello.
Yeah.
I'm sorry, I don't know what happened. It just threw me out
worries.
of the chat.
We
That's what we're
assumed you
discussing.
were trying to demonstrate the failover safety of
Yeah.
power supply of the system, but that's okay. Welcome back, Deb.
Thank
So
you.
Stefan,
So I think
Dave
the
just
data part is very important here, and that is the question that I had next. That can the EMS and what is the data security part here? And you said that 90 gigawatt of data per day, that is a huge amount of data. Neehar, from a 50 gigawatt from the 50 gigawatt project or 90 gigawatt project, so much of data. But is that secured? Is my question.
So so data security is across many layers, right? So there are various links, uh, Satish was mentioning, there are the primary links that are in the plant between the BMS and the EMS, between the PCS and the EMS, all the other ancillary systems of the plant. Now, primarily the protocol of choice today is Modbus, right? And Modbus inherently is not secure. Modbus has no security feature built into the protocol itself. 61850 and certain newer protocols do, but Modbus inherently doesn't. But what we do beyond the EMS at a central level, or when we talk to external systems, to the cloud, to the load dispatch centers, to the asset owner SCADA, those are the layers that can really be protected and made secure by the EMS. And subsequently, as the market matures, moving out of Modbus, moving on to slightly more sophisticated data transfer protocols will be the way things go forward. Modbus is like 50 years old.
Yeah. Interesting. Thank you. I will come to Venkat sir now. Venkat sir, what is Cygni doing in EMS, and can we say that it is 100% domesticated as a product today?
Yeah, yeah. So I'm sure every one of us have some answers to that. But I'll tell you what we do at Cygni, Dave. So we have built our own energy management system, which is also deployed for the last 1.5 years from January 2024. What we have built is an EMS which basically integrates the RE sources, solar and wind, along with diesel generation as well. Predominantly, we have developed it for a C&I application, and of course, we have also developed the HMI user interface, and we have also deployed that in the research park in Chennai, for which we have got the data available. I think Neehar talked about the amount of data and the security. Will come to that. The application is predominantly a peak shaving application, where if the load were to be higher than a particular set value, then the EMS switches on the supply of this large-scale based system. And it also provides the needed control, right? If somebody was to sort of do this on an instantaneous control, it provides that as well. And there are necessary alerts, and all of them are put, right? This is what we have, okay? But the question is that enough, right? In general, right? I think, clearly, I do see that the grid code is evolving. I'm sure other speakers will have a lot more things to say here. But what happens is, based on the CEA Grid Code 2023 guidelines, right? Where it's basically evolving from a very passive, very conventional, grid approach to a very dynamic renewables integrated system. Which warrants a lot of flexibility, which warrants a lot of forecasting and accountability, which also warrants, grid stability and visibility as well. So I think we have got a lot of work to do, because the grid code is evolving. And in order to do that, I think all of us will have to be there. But to a great extent, I think we have got that today. And then now that there is a mandate clearly that, this has to be an indigenous software, I'm sure, I think this is the direction that all of us would be taking to make it more robust. Yeah.
Thank you. So Suhas, I would love to hear from you. what are you doing and what is the product?
Yeah. So we are doing both battery for EV and stationary applications. And while we are serving stationary customers, we are also offering EMS solution. And while I'm also looking at few of the chat questions, so in terms of and what Stefan was earlier also talking about, so the reliability of EMS, because that's the brain. Reliability and security of EMS is very critical, and from that perspective, we are offering solutions which are compliant with not only CA guidelines, cyber security norms, but also the cyber security norms released by Ministry of Electronics and Information Technology. So here is in fact, we are deploying a solution, cloud solution, which is compliant with these MITI guidelines for a project coming up in Mumbai.
Thank you. Neehar?
So I think we at AmpereHour, we're building our own EMS. We've deployed it over 150 megawatt hour of EMS deployments. I think cybersecurity, we talk about it a lot. I still find personally, I may be wrong, but I personally find that there is very little clear guidance in terms of standards on cybersecurity specific to energy. There are general standards on hardware cybersecurity. There are general standards on information security at a server level or transmission, but something along the lines of what California has with the smart inverter profile, very directed, specific guidelines are not really clearly there or clearly implemented. So I think that is a good space, for us to sort of debate and come to a consensus on, how we want to go forward, because it's obviously, really critical, as Stefan mentioned. It's the EMS going down or the EMS having backdoors is highly dangerous for the grid. Can lead to quite catastrophic events.
Right. Thank you. Thank you. Satish, what's on table
Yeah.
from you?
So basically, what we are building is the BMS, right? So within the BMS, we are doing whatever we can in order to support this the overall EMS strategy also. For example, for small applications like 5 kilowatt hour, we have the device also 5 kilowatt hour to 50 kilowatt hour device, just which can replace the like a home UPS or a building UPS. So we do take care of our own EMS, right? So our BMS is capable of talking to the PCS or inverter, and we take its control, and then we manage the power direction and everything. But when it obviously this architecture will not work for the best systems, right? So, but for example, I'll tell you, we were so in our architecture of the BMS, since we are writing from scratch, so both the hardware and the software, we are also implementing this HSE, like the encryption of the data, because data security is going to be very crucial in the future. So we are encrypting the data through the hardware, so that it would be really difficult for anybody to attack. So that is something which has to come from even the subsystem, right? So which we are fulfilling as an obligation to the entire thing. Obviously that has to be supported by other the decoding part also, but this, since BMS is a crucial subsystem of the entire thing, so we are thinking in that direction. Yeah.
Thank you. Kashish?
Just to add on what we have doing, what Neehar has mentioned, so I will just divide the security at different levels. Okay. So like as we executed almost 50 megawatt hour project across different CNI spaces along different grid connectivity. So every thing comes at a different loop. So one is a hardware point. So hardware has to be that no one can access easily. It has to be authorized access and managed switches. Okay. Definitely Modbus is always a riskier deal. That's where IEC 6184 come into play, can come into play, secure can come into play. Okay. Then we have a selection of right set of local servers. So like not anyone can authorize and use the data. Then we have when the data is connected to outside the field. If it is connected to open gateway like internet, then we have firewalls in place. Then we have when the data is in the air, like between the site and to the server, cloud server, there is a protocol, MQTT protocols, and there is like the data should be secure when it's transferring from one point to another point. And ultimately, when it is storing into the server, and specifically the cloud server, the data has to be in the regional boundary of the nation, which is the data has to be hosted within the Indian boundary space. That's the rule. That's a rule which India has, and that's where we also follow. Okay. And once into the server, it has to comply with the server guidelines. Definitely, there is no specific norm for energy sector, but IT segment has already gone way and above beyond the cybersecurity framework. So right now we are copy pasting the same framework what IT segment has, because they know specifically ask for energy segment. This has to be this. So that's where we are copy pasting the good part of some of the industry, which we can follow. Some part is like it will be too much to follow. So we restrict ourselves whatever is good for us and good for the customer.
Interesting. Thank you. And finally, to Stefan.
You
Stefan,
think?
sorry, we couldn't introduce you. So if you
No,
would
I
like to
know, I
introduce
know.
yourself, then yeah.
Okay, very quick. Currently, I'm running a consultancy organization called SIMMOL. But of course, before that, I worked for about 5 years as the CEO, CTO of 𝐂𝐧𝐞 Energy. We built the first gigawatt-hour battery pack factory in Prantij with 6 production lines. And in 2021, I started focusing on building the 6 gigawatt-hour cell manufacturing line in Bangalore. So that's what I've done. In terms of this particular chat, when I heard about the requirement for an indigenous EMS for these VGF-funded projects, and hopefully also beyond that, sorry, I developed a paper that has definitions towards what is an indigenous EMS, which communication protocols should we be using and should we not be using, what are the cybersecurity requirements and reliability requirements, aspects about compliance and verification thereof, policies. So I've put that all together in a bit of a paper, and if we could circulate that in the amongst the team that could work on that to further improve that, we could probably as an industry help the government come up with a good policy. That's aspect number one. Aspect number two is where, see, if you have to start from scratch in the development of a BMS or an EMS, it is quite challenging. And I always joke that, specifically on BMS, then it's probably no different for EMS, that the only good BMS or EMS is the 3rd generation BMS or EMS. Your first 2 generations are learning points. So to help Indian organizations create their own BMS and EMS, my company is offering technology that can be licensed, both for EMS platforms and both for BMS platforms as well as EMS. So that means that you can take a license of certain technology, a technology transfer will follow whereby your team gets trained. And then you can, with that source code, not only take the responsibility of making it indigenous and cyber safe and all that, but also further develop it and add specific features that are required on a project by project basis. So we are trying to help Indian companies take the technology as a starting point, which is developed and proven, and then take it forward under their own roof.
Okay, sure. Thank you. I will come to Neehar once again. And so one thing that I would like to know from you is the standards part and the certifications part for this EMS. Are we competent in proving that, or how are we placed there?
Yeah, so when we talk about EMS, there is the hardware aspect and the software aspect. So today we have very well-known standards for hardware components, whether it's PLCs, industrial PCs, panels. There are a lot of standards and a lot of it's part of the standard electrical infrastructure that we've had for many years. That doesn't change.
Okay.
Specifically to the software development that makes an EMS, talking to your batteries, PCS, grid, market interactions, and so on. There aren't really any clear standards that exist outside of a few use cases in Europe, a few use cases in the US, which are specific to our grid code or our country, right? Like, okay, this is what I need from an EMS software. If we pass these 10 tests, then you're certified at an application level or at a EMS level. That I have not been able to find, or we've struggled to find. Like Kashish said, like we take some best practices from the IT sector, we take some best practices from the general industry 4.0, and we merge it into something that is what we feel is reasonably good. But I think there's a lot of scope for a development of a standardized structure, both on the hardware and the software.
Great, thank you. And second is Kashish, coming to you. With this technology innovation taking place, constantly changing chemistries as well as cell sizes, and it will keep on going like this. Is EMS that I put forward in a system valid for even a technology or maybe a parameter change in this technology as we go forward? Does it fit in good?
Yeah, so Debmalya, as long as the communication protocol, as well as the language remains the same. I speak in English, you speak in English, I can understand data. Okay. The only thing which I need to augment the software part, which is definitely need to upgrade it part. So that's where my point is that whenever we choose an EMS, it's not like day one. It doesn't commission on day one. In commission, it gives you a proprietary data on day one, but over the time it evolves. The requirement changes, the parameters changes. Okay. As long as I speak in English, you speak in English, we can understand.
Amazing. Thank you for that. Okay, Venkat sir, I will come to you. If I want to go ahead and purchase a EMS, what should I be looking for, or what should I be asking for to the supplier of the EMS? Venkat sir is okay. I would request if
Debmalya, I can take this question. In fact, I have replied to same
please,
question in
please,
chat also.
please.
So while all EMS are like managing the different sources of energy in the system, so critical part is reliability and scalability of that EMS. So today, if I'm setting it for say certain capacity, tomorrow I want to expand the capacity. It should be scalable. Then from Indian context, it has to be compliant with grid codes. In fact, that EMS supplier should have its own software simulation model, which generally required by grid authorities for simulation purposes. Then also strong sales and service support, after sales service support, because that's a challenge with we have been facing with foreign EMS companies when it comes to serve the customer on field. Availability of skilled manpower is a bit challenge from companies who are not having base in India. And obviously then cyber security, and these are the 2-3 things which are critical when I am selecting an EMS, because otherwise everyone is using similar hardware, and maybe some people are using embedded PC, some are going with PLC, some are doing with IPC. So computational power wise, there is not much of the difference, but these 3-4 points which I mentioned makes a lot of difference when it comes to operating that plant in long term.
Thank you. Thank you. Venkat sir, I would come to you, and knowing a bit more about warranties and guarantees, which comes under the purview of the EMS. What would like to hear from you?
Yeah. So today, I think Suhas talked about the support in a way that is, I think that's going to be very critical for EMS for two reasons. One, today India is predominantly focused on a single application. Almost all the best tenders. I know it's very close to your heart as well, Dave. We are going to see this going to evolve into a multi-stack, multi-application model, right? So which means that you are not going to ring fence your best for a certain application, but you would want to sweat your asset. And in order to do that, of course, the grid code will have to evolve and EMS will have to play a very big role. Okay. So what it means is that today, whether in terms of the evolution in terms of interoperability and the standards which are going to be there, and then coverage of use cases, right? The CEA grid code to a great extent talked about, for example, forecasting and accountability. They have covered to some extent in the 2024 grid code model, but it still needs to sort of go much farther. So going back on that, so today warranty to an extent what is available would sort of meet to some extent, but it is not going to cut it as more applications evolve. You would need this EMS to be very flexible, right, in a way that so that the sweating of the asset can happen. In order to do that, so the choosing of the EMS vendor, one, and number two, making sure that support happens as the grid code evolves is going to be another critical thing. Both of them will have to happen in an Indian context. Because it's all the more reason where there is a lot of changes are happening on the grid code is how I would put it, Dave, actually. Yeah.
Thank you. Thank you. Satish, would like to hear from you as to who are these, so the hardware part. Are we presently importing it, or are we a part of it is domesticated in India? How is it working?
So the thing is, I don't think, we need a very brand new hardware, for the EMS to run the EMS. Maybe, panelists can correct me if I'm wrong, but what I would say is, because we need an industrial PC or, edge controller, which are, already here, widely used in other industries as well. And also communication, these ports, channels, also everything is, kind of established already. So what we need to build is more kind of a we need to build a standard so that the EMS will talk to all these heterogeneous applications and ultimately to the grid. Yeah.
Thank you. Thank you. Stefan, coming to you, I would like to know the economics. How does the economics of the EMS work?
So there are essentially you could break down all the services that an EMS software, as someone mentioned earlier, a battery is just a storage device, and unless you put an EMS on it, it does nothing. The EMS itself can do a lot of different things, and it breaks down into what I would call economic or market services versus technical or grid services. Economical are the ones that return a revenue. Someone pays you for providing that service, or the service itself. For example, I buy electricity when it's cheap, I sell it when electricity is expensive, I make a margin. That's a use case. That's something that I would call an economic or a service. Market services are still very limited in India. Maybe some arbitrage and then kind of it, but there are many like peak shaving, load shifting, demand response, renewable integration, of course, capacity planning, carbon reduction. I don't know. Those markets don't really exist much in India yet, but I expect they will further be developed. In terms of the technical services, a very simple one to explain is black start. If a part of the grid fails, you need to restart it. How do you do that? Well, by using a battery which has energy, you start putting the grid, bringing it back to life. But there are many technical services like frequency regulation, voltage support, spinning reserve, congestion relief, inertia provision. I think I could name probably 20 if I think for a few minutes. And all those services are required to run a stable grid. And it is the grid operators who have responsibility to run a stable grid that they need to buy into services. That's typically how it goes internationally, that they pay service providers to to help them keep the grid stable and run.
Thank you. I would like to hear from you how competitive are we when compared to other EMS coming from other countries?
So just to add on Stefan, and as well as how competitive we have to be competitive if we want to be in the market. That's a status quo. I guess Neehar and other people who are making the indigenous EMS must be answering this question day in, day out. But one thing is, we as a company, as an industry, might not have that gigawatt of megawatt of experience that goes into the ground. But we do know, because this EMS, as my colleague mentioned, it is the hardware and something is nothing new. It was there into the market. We have power plant controllers, we have everything into the market. The only new component is the battery and understanding of battery and how it functions. That's the only know-how and knowledge which come into play. Okay. So when we pick all these things together, we have been providing a solution which is technically competent and commercially viable. And we have been seeing we are sitting neck to neck to the player who are having the multi-megawatt gigawatt scale of installation globally.
Cool. Neehar, would you echo that or?
No, absolutely. I agree with what Kashish said and what Satish has said as well. That look, the hardware is nothing new, right? We are talking PLCs. PLCs have been around for 50 years. We're talking industrial PCs, embedded PCs. It's all standard hardware. It's the knowledge of BESS, how BESS functions, how to run a battery safely, how to work with inverters, how to manage your auxiliary systems, how to reduce your overall downtime. Is what makes a good EMS. And I think software capability is something India has always had. And it's time to basically leverage that to build on top of the building blocks that already exist. So I think it's quite feasible for us to be globally competitive.
Amazing. Thank you. So, Satish sir, I would come to you, Venkat sir. Venkat sir, is it okay for me to therefore comprehend that domestication of EMS in the entire value chain would be the easiest or the most, I won't say easiest, but the most viable one at present?
Oh, very loaded question, Dave. I don't know whether, yeah. Yeah. So let me see. Today, I think we got to truly understand that the development of various pieces which are required for an EMS. If you had to pick, one country which is, very well, sort of positioned to do that, it would be us, right? Because of the fact that, we have been sort of on the IT and software and cyber security. I think we have got a lot of talent available. That is one. Number two, we also believe that I think the notification, which is very clear, saying that the software will have to be, indigenously done. They have not talked about the hardware at this point of time. Is also clear, because that also sort of expects that there is going to be the grid code is going to be continuously evolving, right? So for us today, I think the need is very clear. Okay, now to answer your question, is that the easiest part? I would not say that, Dave. Okay, I truly echo what Stefan said in the beginning, that it is one thing to come up with an EMS hardware and software and then make a plant work. But it is entirely different beast to make it that it is as reliable, as fail-safe, as as robust to build that, because that becomes truly the brain of the the whole this thing, right? So we have got a long way to go, but this is a first good start, is what I would put it, Dave. Actually, yeah.
Thank you. Thank you.
Just a small point to add to that. I fully echo what Venkat sir is saying. I think we look at the EMS as job done when we decommission the plant, not when we commission the plant, because it's really the EMS's job to maintain the plant, make it viable, make it safe, and generate revenue for the lifetime of the project. So the EMS job is really, when we decommission, and that's when it's job done.
Mm. Thank you. Satish, we have a question, and I'm putting up a question from the Q&A box. How does EMS control load balancing of multiple containers?
The thing is, we need to obviously, right? Because we get the data from because every container may have modules. Will have modules, and though from those modules we have maybe according to the architecture we have a centralized BMS or multiple BMSs, right? And then the data comes to the EMS, and then the EMS job is to control it as a single system, right?
Mm.
So that's where the expertise or the true function of the EMS comes in, right? So the load balancing again we have to interface with the grid also. How much load it is requesting, right? So so in that way, it is pretty much in control of the EMS. To manage all these sub modules or subsystems. So I think that would be quite possible. Yeah.
Yeah.
If I can add to that, what Satish said. So, when we look at a utility scale plant, let's say you have 100 megawatt of power and 200 megawatt hour of energy, and you have 40 containers that you want to split power into. I think the first thing that the EMS needs to do is act as a layer of abstraction between what is outside of the plant and what is inside the plant. For the grid operator, for the asset owner, for anyone who is using the best to trade, it really should not matter whether you have 40 containers, 80 containers, how much they are charged or whatever. The distribution of power internal to the plant should be completely irrelevant to the person who is sitting outside. And that's a core function of what the EMS needs to do. Now, once the EMS gets a command, let's say I want to deliver 80 megawatt and I'm capable of delivering 80, then the distribution question depends on what the underlying application of the asset is, whether it is more important for me to deliver maximum power, whether it is more important for me to keep all the containers balanced, whether it's more important for me to make sure that all my PCS run at a certain efficiency. So the objective function can change, basis what the application it is built for. But this is a configuration that happens every time we set up a plant.
Yeah. Yeah. Thank you. Stefan, there's a question in the Q&A box. There is IEC 62443 standard are generally mentioned to comply. How are we complying this in EMS or network level?
Yeah, that's as it happens the standard that I also put in my paper. I think that's a very good start. Where I personally struggle a little bit is, as was mentioned before by Neehar, the Modbus protocol, for example, which is probably the most popular protocol, can't really be made safe, isn't safe. Someone can jump over the fence and, if they want, integrate a Modbus backdoor, and then all sorts of things can happen. So I think we need to take a closer look if a fence is considered safe enough or not. But yeah, that standard is, I think, is kind of the starting point.
Okay. Thank you. Thank you. Satish, okay, you have two options. One, what is the way forward? Or second, if you had a single wagon to pull through and ask the government for a support on this EMS implementation, so what would you pick? And yeah, your answer.
So I would go with the way forward, what we are supposed to do. I think certainly it is for the builders of EMS such as Cygni or AmpereHour. So this is a very good chance for them, right? So this is the opportunity for us to make the systems robust, and also I'm sure they might have implemented up to certain sizes. Now we have the opportunity to go into the gigawatt our storage as well, right? So this is a great opportunity for us, but even for others as well. I think government is clearly communicating one another thing, right? So I think this the domestication of this EMS also signals that there could be more coming up in the value chain. Maybe we are expecting the BMS actually, right? Because through BMS you can also control from the internet directly, right? So considering the geopolitical situations, this could be very dangerous for the country. So probably BMS could be the next thing, and also there could be other components that could follow the same fate, right? So I think way forward is, I think it's I really like, because whenever I heard this mandate, of course I think there could be some time could be given, but the larger industry echoes that I think it is the need of the hour, and we are moving in the right direction, and this is a good opportunity for us to build on top of it. And not just this, but also you have the export opportunity as well, right? Because once we make this solution as we work indigenously, the next option for us is the export market as well.
Yeah.
That just to
Thank
add
you.
on what Satish is saying, the way forward of the EMS is when we have multiple projects. As you are saying, one IPP, I am having multiple projects. So I can look at applications tracking. I can look at my portfolio level management. I can look at using this battery at this source to deliver whatever the deficit was there because of my solar DSM penalties in somewhere else. As we are talking of one nation, one grid, it will be like one portfolio. One batteries are elsewhere, the solar and EMS assets are everywhere, but all is acting as a one resource. Obviously, we need to look at the obligation of the PPAs and the obligation if the government allows for it. But it can be a good thing or a top layer of EMS which we can look at. We can look at, as you mentioned, the cyber security part. It is a must. We can look at some standardization happening for the energy sector, because now everyone can be having a same playing board, like level playing field for everyone. So otherwise, someone is offering something, someone is offering something. We can see as the regulation coming in, very much small, the budding up of different EMS player coming into picture, different system solution provider coming into picture. That needs to be standardized. Otherwise, we can see another incidents happening on the ground.
Yeah.
So that should be being governed.
Thank you. Neehar, you don't have an option but to choose the second one.
No, I think I echo what most of these guys. So I was just also looking at the questions to see if there's anything that I can help with.
Yeah. Let me go for the second one, Deb. I think.
Please.
Yeah. Yeah. So see, today I think this notification is a one-liner, right? Saying that the application software for the EMS shall be developed indigenously, right? I think it's very important for us to now drill down this to focus on specific parameters, what we mean by this, right? In terms of what should be the core functionality, how do we handle the stability of the EMS, how do we handle the cyber security, how do we look at the alternate to Modbus we talked about, because many of the tenders today are very clear in terms of, IEC 61850, DNP, all of them are there. But I think the next level would be to drill that down and specify on the functionality, what we call it as an EMS, right? So I think that's where I guess that you can play a big role, IESA can play a big role, and we can all support. I think that could be the way we can drill it down, saying that just don't look at the source of origin of the software, but what do we need for India, and then that would be a great ask, is how I would put it, Dave. Actually, yeah.
Amazing. Thank you, Stefan. Well, you said about a white paper. Where is it available, or how can it be? How can people get access to that?
Yeah, it's on my computer. So yeah, and then I need the help from IESA, I think, to distribute that, or whichever way you want to manage that. I think very important is definitions. What does it mean, indigenous? What is the scope of EMS? Does that include the cloud analytics, or is it just a site controller? So I have a lot of questions. I think first of all we need to create clarity on what is intended here, and then, as Venkat said, what does India need, and how do we, combine that? Now, as I mentioned in the beginning, I do believe that fundamentally I understand why this has come up. it's fair, it's correct in my view. But yeah, we need to agree on something that makes sense for the industry, that propels the industry, and doesn't, become a restrictive thing. That I think is important. And I think that's what I try to do in the paper. So I can share that with you. I still have to maybe cross some T's and dot some I's, but by the end of the week I could have it with you.
Okay. So with that, I extend a very, very, very heartfelt thanks to all of you for being a part of this. And just how interesting the topic was, we had 95 participants participating here and hearing you all. So thank you for being such a sport and coming down and to talk to me. And we wish you all the best. And we hope you get great opportunity in this market. Thank you.
Thank you.
Thank you, Dev.
Thank you, everyone.
Thank you, Dave. Thanks so much.
Bye-bye.
Thank you,
Bye-bye.
everyone.
Bye bye.
Bye.
Bye-bye.